Good morning, guys, all of you. Today I'm going to discuss about introduction to version control system. Here in this topic, I'm going to discuss about need of version control system, how version control system work, and the basic terminology of version control system, and benefits of version control system, and the types of version control system. Guys, there are two types of version control system that we are going to discuss about. One is centralized version control system, another one is a distributed version control system. Okay, let's see first exactly what exactly the version control system. And version control system is also known as what? Software configuration management, guys. Version control system is also known as, see, version control system, which is also known as software configuration management, guys. Software configuration management, SCM, or source code management system. We can also call it as what? Source code management system. SCM, source code management system. Version control system you can also be called as what? Software configuration management system or source code management system. See, let's put the heading need of version control system. Need of version control system. Version control system or source code management system, whatever. Source code management system or version control system. Let us say, being as a developer, let us assume that I'm a developer. I'm working in a particular reputed MNC. Being as a developer, my job is to what? Write the several files, right? Whenever the requirement is there, whenever requirement comes, as a developer, I have to write several files, okay, which contains source code. As a developer, I need to write some code, right? That generally whatever the code which I have written will be stored in the form of files. That file, it may be a Java file, it may be a Python file, or it may be a PHP file. But as a developer, my responsibility is to write the code to different files. It may be a Java file that may be a Java file or Python file or PHP file. Let us say one client is there. Okay, client approached me to develop a project. So for that client, let us say I have written 100 files, guys. I have written 100 files. Let us say those 100 files are Java files. As a Java developer, uh, to do the client project, I have written 100 files. I developed 100 files, guys. And client suggested me some, after developing 100 files, I thought that the project is done. Okay. Then client approached me, client suggested me some changes. I changed some files, guys. I have changed code in few files to meet the client requirement. Let us assume that according to whatever the client suggested me, accordingly, I have changed source code files, which I have written to meet the client requirement. And I completed according to the uh, client requirement, and I gave a demo, and client suggested me some more changes. Okay, client suggested me some more changes. I changed some more files according to meet the client requirement. Okay, to meet the client requirements, again I went for what? Changes in the source code. So the existing files only I overwritten according to the client requirements. Okay, whenever client suggested me to changes, accordingly I just overwrites all the source code which I have written, all the source code files which I have written. And I gave a demo for third time, guys. I completed and I gave a demo to the client for third time. Client asked me for the first version only. Okay, he didn't satisfy the second and third versions. Okay, again he go back to first version and he asked me to give first version only. Since I have overwritten the first version, whenever he suggested me for the second time, okay, and third time, I lost that first version, right? Yeah, what I understood that I would have not overwrite the first version when he suggested me for the changes in the next time. I mean, second time or third time. I would have maintained all the versions, right? That's the reason why in such a cases, version control system will come into picture. See, whenever you finish the project, okay, we have to maintain it as a separate version. Okay, whenever client asked me to work, whenever client suggested me for the changes, okay, without overriding the first version source code files, okay, I have to maintain it as a separate version, and I can go for what I have to go for what modifications in the existing source code, okay, uh, and that would be maintained as what second version. This is how whenever client suggested me for the changes, I should go for changes according to according to meet the requirements of the changes of the client, and I have to maintain it as a separate version. So we should not override the source code. Every version we have to maintain because we don't know at the end what the client will ask. Okay, which version the client will ask, we don't know. That's why the best programming practice is to maintain all the versions. Okay, that's what we should not think when the client suggested for some changes the next time. Okay, we should not think that uh, he will not stick to he will stick to that requirements. Okay, the client requirement may keep on changes. Okay, I don't know what version he may ask. Okay, see, see in the case which I explained just before. Okay, when I completed the project, he asked for what, he asked for changes two times, right? Later two times, but after making modifications in the existing source code for the two times, again he asked for the first time what I have shown you, what I have shown him. Since I didn't maintain that first version, I lost the code of first version. Okay, when the second time when he asked, I overwrites the first version code. That's why I lost the first version code, but like at last he asked for first version code only. What we have to understand from this, we have to understand from this, we have to maintain every version, because we don't know what the client will ask us. Okay, at the end, that's why the that's why we should not override the code. Okay, every time, every version we have to maintain, okay. See guys, that is the story behind this. Let us say, being as a developer, we have to write the several codes, right? Several source files or source code files. And we should not overwrite our code. See, we should not overwrite our code. Every version, every version we have to maintain. Now, here we need to discuss some of few important points. Maintaining multiple versions manually is very complex activity, right? Maintaining multiple versions manually is very complex activity. See, first time when client approached me to develop a project, according to the client requirements, I developed 100 files, right? Yeah, but when I gave a demo to the client, he suggested me for changes, right? And I have to start uh, I have to start it as a separate version. Okay, the first time when I have developed that should be a first version. And when the second time the client suggested me some more changes, and whatever the changes that I am going to develop to meet this client, to meet the client requirements for the second time, I should maintain it as a version 2. And the third time when he suggested me for any changes, uh, according to the meeting the requirements of the client for the third time, I need to maintain it as a third version. See, maintaining multiple versions manually is very complex activity, guys. Okay, complex activity. Then this version control system, this is an automation tool. Then the version control system will come into picture, whose job is to maintain, whose job is to maintain all versions of the source code, all the versions of the source code. See, maintaining multiple versions manually is very complex activity. See, maintaining multiple versions manually is very complex activity. Let us say another point. Let us say there are two developers, developer A and developer B, working on the code. At last, we have to merge the code developed by both the developers and we have to deliver it to the client. If the developers developed, see, if both the developers developed a file named with util.java, okay, then one copy will override another copy or not. Both the developers developed a file named with what? Util.java. Then one copy will override what? Another copy, which creates abnormal behavior. We should not override our code. We should not override our code. The file name must be what? Unique. Okay. Generally, when two or more developers works for a single company, okay, the file name must be unique. The file name must be unique. That's what. And let us say developer A and developer B working on the code, and developer B working on the code. At last, we have to merge the code developed by both developers, and we have to do, and we have to deliver it to the client. If both the developers developed a file, developed a file named util.java, let us say util.java, then one copy will overwrite one copy will overwrite another, guys. Another one copy will override another. When the both the developers try to change the same file or try to develop a same file, okay, one copy will override another file, which creates abnormal behavior. We should not, otherwise we should not overwrite our code. That's what, guys. The file name must be unique. When more than one developers working for the same company, the file names must be unique. And here, every change should be tracked, guys. Every change, when group of people working for the same project, okay, every change, any change which is made by the developer, okay, must be tracked. Who did the change, when he did the change, and which changes he did, etc. All must be tracked. Every change should be tracked. Like who did the change, who did the change, and when he did, the change, and which changes he did, and etc. All these things must be tracked, and all changes should be maintained, guys, and all changes maintained. And let us say, and overwriting of the code should not be happen, guys. And overwriting of the code should not be happened. And developers who have to share their code to peer developers, okay, so that multiple developers will work in a collaborative way, guys. Developers have to share their code to the peer developers so that multiple developers will work in collaborative way. And parallel development must be required, guys. Parallel development must be required. Let us say developers have to share developers must or have to share their code to peer developers so that multiple developers the multiple developers will work in collaborative way. And one more important point is parallel development must be required, guys. Parallel development must be required. To release the project in time, parallel development must be required. See, these for all these, to achieve all these points, we need a version control system, guys. We need a version control system. So see here, maintaining multiple versions manually is very complex. Then on behalf of us, who will do that? Source code management. That is version control system will maintain that. Okay, you need not bother about maintaining of the different versions of the source code. Right? When developers, more than one developers working for the same company, okay, if they try to write the code with the same name, obviously one file will overwrites with another file, right? This is how we will lose one copy, and which creates an abnormal behavior, guys. We should not overwrite the source code. We should not overwrite our code. We should not override core code. And every change must be tracked, guys. Should be tracked. Like who did the change, when he did, okay, what changes he did. All this must be tracked. Keep tracked, okay. So by our version control system. See, all the versions should be, all the changes should be maintained in different versions, in terms of different versions. Like overriding of the code should not be happen, guys. Should not be happened. And developers have to share their code to the P developers so that the multiple developers will work collaborative way. And parallel development must be required. Okay. To achieve all these point, one must need what version control system. These are the requirements which will be fulfilled with our version control system. That's what, guys. And let's see how version control system works. Let's see how version control system works. Just now we have seen what are the requirements. Okay, what are the requirements of or need of version control system that we have seen, right? For what the version control system is required, that we have seen. Let's see how version control system works. See, version control system always talks about what? Files, okay, which contain source code. It always talks about what? Files which contain some source code. Source code means what? The program, the code which is written by the end users are known, programmers are known as source code. Version control always talks about files which contain source code. Everyone required version control system to maintain different versions of their document, guys. Everyone required version control system to maintain different versions of their document. Let us see tester. Tester also require what? Version control system to maintain different versions of the test scripts. And architect also need version control system to maintain different versions of the document. And project manager also requires version control system to maintain different versions of Excel sheets, etc. etc. This is how every person in the development environment requires this version control system. As a developer, as a developer requires to maintain the different versions of their source code. Tester to maintain the different versions of the test scripts. Architect to maintain the different versions of documents. Project manager to maintain different versions of the Excel sheets. Like, let's write few points about it, guys. How version control system works. Version control system always talks about files which will files which contains source code, guys. Source code. This is version control system always talks about files which contains the source code. And everyone required what? Everyone required version control system to maintain different versions. To maintain their documents. See, let us say developer. Okay, developer is what? Why developer maintains a version control system or need version control system? Maintain different versions of source code. Let us say tester to maintain different versions of test scripts, to maintain the different versions of what? Test scripts. And architect, see, to maintain different versions of documents. And if you take a project manager, to maintain the different versions of Excel sheets, guys. Etc. Guys, etc. Let us see how the version control system would be. See guys, this is how the version control system. See, this is this is the version control system architecture, guys. This is working directory where the developer works. Let us say he has written three files: a.java, b.java, c.java, guys. a.java, c, b.java, c.java. See here, a dot, b dot, c dot java, and he committed the changes to what local repository. Okay, every version control system maintains one repository, guys. In that, he'll commit it. Once he has written, okay, he has committed the changes, right, to the local repository. See this repository. Whenever he go for what modifications, it has to maintain. See version one, version two, version three. Let us say the source code in the version one. This is what the client asked. The second time then the client suggested the files maintained, I mean the version maintained like this. Okay. So when the third time client suggested, okay, according to the client changes, client requirements, this is how the third version is maintained. This is how the different versions are maintained in the local repository, guys. A repository under version control. This is a repository where we store all the different versions of our source code. That is how every version control system maintains its local repository to maintain the different versions of the source code. Uh, See, this is the working directory where the developer works. And if any changes, okay, required, the developer check out that code. Again, once the checkout is performed, okay, all the source code will be again comes to what working directory. According to the changes, he'll go for what modifications. Once modifications are done, that will be maintained as a separate version. This is what will happen internally in the version control system, guys. Different versions, see, different files will be developed. Once the development of all the source code is done, written, that will be committed to the local repository. Local repository maintain it as a separate version, that is version one. Okay. If the client suggested for changes, and then the developer will commit what a checkout operation. I mean, he will perform checkout operation. Then he will go for what modifications to meet the client requirements, and then that will be maintained as a, and then you will perform commit operation, and that will be maintained as a version 2. And if the client asked some more suggestions, okay, to fulfill the client requirements, he'll perform checkout operation, and then uh, that will be brought to what again working directory from the local repository, and he'll go for maintaining some, he will go for changes to meet the client requirement for the third time, and then he'll perform commit operation, and that will be third version, that will be maintained as a third version, guys. This is how the different versions of the source code are maintained by the version control system. That is what, guys. Now, let's see. Let's discuss the basic terminology of version control system, guys. The basic terminology. Version control system. VCM, VCS. It means what? Version control system, guys. Basic terminology. Okay. See, working directory first. Working directory. What is this working directory? These are the basic terminologies, guys. See, where developers are required to create or modify files. This is the place where developers are required to create or modify the files. What we call it as working directory. where developers are required to create or modify files. That is working directory, guys. Here version control is not applicable, guys. Here version control is not applicable. Here we won't use the work like version 1, version 2, version 3, etc. Okay, this is not working directory, do not comes under version control system, guys. Okay, here we won't use the work to maintain like sorry, to maintain like version 1, version 2, etc. Okay, etc. Working directory do not comes under version control system. See here version control is not applicable. Version control is not applicable under working directory. Working directory is the place where the developers are required to create or modify the files. That's all. And let's see what is repository. Repository, guys. See, repository is the place where we have to store the files and metadata, guys. Where we have to store files and metadata. Metadata means what? Data about database. Which file? When is it created? What is the file name? These are all comes under what? Metadata, guys. Metadata. And the file which contains source code, okay, is a file. Where this is repository is a place where we have to store files and metadata. Here version control is applicable, guys. Here version control is applicable. And see here we can talk about versions like what? Here we can talk about where we can talk like or we can talk about versions like version 1, version 2, etc. guys. Now I hope everyone understood, guys, what is repository and what is working directory. Fine. Now next terminology is commit. Just now we have seen all these terms in the diagram, right, which I have shown you the working style of the version control system. In that we have seen, right, repository, local repository, what is working directory, what is commit, what is checkout. See, commit is a process of sending files from working directory to the repository, guys. It is a process. It is a process. It is a process of what? Process of sending files. Sending files from working directory to the repository. See, commit, whenever you perform this commit operations, okay, whatever the files that we have developed under working directory will be sent to what? Repository, guys. Repository. That is what the commit. And checkout, guys. Checkout. Next terminology is what? Checkout. CHECK, checkout. See, the process of sending files from repository to working directory. Okay, whenever you go for modifications, okay, whenever the requirement is to modify the source code, then we have to perform which one? Checkout. So before that, the whatever the code which you committed will be maintained as a separate version in the repository. Okay, once you perform checkout, that version will be available. Okay, its duplicate copy of that version is available to the working directory. Okay, and if you make modifications in that copy, and again if you perform commit, that will be maintained as a second version in the repository. This is what will happen at Backbase. What is checkout operation? The process of sending files from repository to working directory. This is what, guys. Hope everyone understood. What is checkout? What is this is checkout operation. Working directory, repository, commit, checkout. Let's see the benefits, guys. Let's see the benefits of version control system. Benefits of version control system or source code management. SCM. Version control system is also known as what? Source code management, SCM. Now let's see what are the benefits of version control system. See, using version control system, we can maintain different versions and we can choose any version based on client requirement, guys. Since version control system maintains different versions of the source code, okay, we can maintain or we can choose any version based on the client requirement. If the client asks second version, yes, we can deliver it to the second version. We can deliver it to the client, the second version. Like that, since version control system maintains the different versions, we can choose any version based on the client requirement. That is the first point, first advantage, guys. And the second benefit is with every version, we can maintain metadata like a commit message, who did the changes, when he did the changes, what changes he did. Okay, these are all comes under what? Metadata. Okay, every version control maintain what? Metadata like commit message. Okay, who did changes and when he did changes, what changes he did. Okay, this is advantage. With every version or a commit, we can maintain a metadata like commit changes, commit message, who did the changes, when he did the changes, what changes he did. And the next advantage of this version control system is developers can share the code to their peer developers in very easy way, guys. In very easy way. Developers can share the code to the peer developers in very easy way. That is another advantage of version control system. And next one is multiple developers can work in a collaborative way and parallel development is possible. Okay, we can provide access control like who can read the code, who can modify the code, these access privileges, and we can provide access permissions or access control. Okay, using this version control system, who can read and who can modify, all these access controls can be provided by our source code management or version control system. Let's list out all these points, guys. The first point is what? First point is what? We can maintain different versions, right? We can maintain different versions and we can choose any version based on client requirement. This is the first advantage. Let us see what is the second advantage. Okay, with every version or with every version or commit, we can maintain metadata like like commit message, and who did the change, who did changes, and when he did, and what changes he did. See, using version control system, it is possible for to maintain what all these metadata, guys, metadata. And the next version is what, guys? What's the next version? Developers can share the code to their peer developers in very easy, guys. Developers can share code to their peer developers in very easy way. In easy way. And the next advantage of version control system is multiple developers can work in a collaborative way, guys. Multiple developers can work collaborative way, guys. Collaborative way. And parallel development. Fifth one is what? Parallel development. This is the last advantage is what? We can access control. We can provide access control. Like what? Like what? Who can read? Who can read my file? Who can modify code? These are the different advantages of version control system, guys. Right? Now, next one, types of version control systems. Types of version control system. So how many types of version control systems we have? See, there are two types of version control systems, guys. And one is there are two types of version control systems. And what are they? First one is centralized. Centralized version control system. And the second one is distributed, guys, or decentralized, whatever. Distributed or decentralized version control system. Centralized version control system and decentralized or distributed version control system. Let's talk about one by one, guys. One by one. First one is centralized version control system. Centralized. Put the heading centralized version control system. Let's talk about this. See, the name itself indicates that this type of this type contains only one centralized repository. Yes. There would be only one central repository exist, and every developer should be connected to that repository only. Centralized, it means what? There would be a single repository, every developer needs to connect to it. That's what the central repository is. The total project code will be stored in the central repository itself. Okay. If let us assume that if four developers are there, okay, still we have only one repository. Fine. Four developers should need to connect with the should connect with what? Centralized repository only. Okay. See, this type of version control systems is very easy to set up and use, guys. This type of centralized version control systems are very easy to set up and use. Examples are what? The CVS, SVN, okay, Perforce, TFS, clear case, etc. There are different centralized version control systems available in the market, the which are CVS, SVN, Perforce, okay, TFS, and clear case, etc. Guys, see the name, the name itself indicates that this type of this type contains only one central repository, and every developer should be connected. Every developer should be connected to that repository. To that repository. That's all, guys. See, the name itself indicates that this type contains only one central repository, and every developer should be connected to that repository only. Fine. Let us say the total project code will be stored in the central repository only. Okay. The total project code should be stored in the central repository. Central repository. And if 4 developers are there, see guys, how the central repository would be there if 4 developers are there. If the 4 developers are there, see this is how, guys. There are the developer one, developer two, developer three, developer four, guys. See, 4 developers needs to connect with the same central repository, guys. See, 4 developers are there. Still, we have to maintain what? How many central repositories? There would be a single central repository. 4 developers need to store all their files in the same central repository file. That is what, guys. Okay. This type of version control systems. See, once the code, once source file, I mean, once writing of the source code is done, developer has to commit their code to the version control system. And again, if you want to go for any modifications, he has to perform what? Checkout. This is how every developer will commit and checkout, will perform commit and checkout, commit and checkout. But all the different versions of the developers will be maintained in the centralized repository server, guys. Different versions of the source code uh, is maintained in the central repository for all these 4 developers. This is how the version control system architecture for 4 developers, guys. This is working directory, right? Working directory. When you perform commit, then the central repository will come into picture. Their versioning is paid, versioning is performed. Different versions of source code. For every commit, there would be a version. For every commit, there would be a version in the central repository server. Now see, guys, we are talking about centralized repository only, centralized version control system only. Okay. This type of version control systems is Very easy, guys. Very easy to set up. Easy to set up and use. Examples are, there are so many version control systems in the market. Okay, CVS, CVS, and SVN, and Perforce, Perforce, TFS, and Clear Case, and etc. Guys, these are all comes under what? Central repository, guys. Centralized version control system. And the second one is, see, yeah, we didn't discuss about the problems of centralized version control system, right? There are so many problems with the centralized version control system. Central repository is the only place where everything is stored, right? Central repository is the only place where everything is stored, okay? Which causes single point of failure, guys. Which causes what? Single point of failure. The major drawback of this one is central repository version, centralized version control system is the single point of failure, which causes a single point of failure, guys. If something goes wrong to the central repository, then the recovery is very difficult because it causes what? It causes what? Single point of failure. Single point of failure. If something goes wrong to the central repository, then the recovery is very difficult. Entire data will be lost, guys. Different versions of the source code will be lost because there is a single point of failure, right? There is a every code, different versions will be maintained in the different versions of the different developers will be maintained in the single server. That is single point of failure. It's a major drawback. And the another drawback is what? All commit and checkout operations should be performed by connecting to the central repository via the network, right? If the network is outage, then no version control to the developer. Fine. Yeah, all commits and checkouts operation should be performed via what? Connecting to the central repository via what? Network. Okay. All commits and checkout operations should be performed by connecting to the central repository via the network. If network is outage, then no version control to the developer. This is another major drawback, guys. Developer workspace and repository server should be connected always. Am I correct? In order to perform commit and checkout operations, okay, developers workspace and remote repository server should be connected always, without depending on the network. This is second drawback, guys. And all commit and checkout operations should be performed by connecting to the central repository via the network, okay? Hence these operations will become what? Slow, which causes performance issues. No local operations, okay? Every version control operation should be a remote operation, okay? Everything is remote, right? Everything via the network, it has to connect center, client, developer has to connect to the central repository via the network, and he has to perform what? Commit and checkout operations. Remote operations he need to carry out every time. All the developers, since they are performing remote operations, okay, it affects to the application performance. That's what. Organization of central repository very complex, guys. Organization of central repository is very complex. If number of our developers and files increases, organization of central repository is very complex. These are the disadvantages that we have with what? Centralized repository. Okay, centralized repository. Let us see the problems with centralized repository, sorry, centralized version control system. Let us see what are the problems. The first problem is what? What's the first problem? Central repository is the only place, right, where everything is stored. Okay, since everything is stored in a single place, which causes single point of failure. This what, guys? Which causes single point of failure. See, since everything is stored in a single place, that is centralized version control system, which causes a single point of failure. If something goes wrong, to the central repository, then repository, repo means repository, then recovery is very difficult, guys. Recovery is very difficult. This is the first disadvantage. And the second disadvantage is all commits and checkout operations should be what? Performed by connecting to the central repository, guys. All commit, checkout. All checkout and commit operations done by connecting central repository via network. If network outage, then no version control to the developer. This is the second drawback, guys. And the third one is all commits and checkout operations should be performed by connecting to the central repository via the network, right? And hence these operations will become what? Very slow, which causes what? Performance issues. No local operations, right? And every version control operation should be a remote operation. Okay. Now, see, since no local operations, and every version control operation should be remote operation, which causes or hence operations will become slower. Operations will become slower, which causes performance issues. That's always. And the fourth drawback of a centralized version control system is what? Organization. Okay, organization of central repository is very complex, guys. Organize. Very complex. If number of developers developers and files increases. These are the different drawbacks that we have with the centralized repository, guys. Since everything is stored in the single place, okay, which causes single point of failure is the first major drawback. And the second one is what? If see, if something goes wrong to the central repository, then the recover is very difficult. And all commits and checkout operations are done connecting to the central repository via network. If network is outage, then no version control system to the developer. Okay, since no local operations and every version control operation should be a remote operation, right? Hence operations will become what? Slower, which causes performance issues. That is the third drawback. And organization of the central repository is very complex if number of developers and files increases, guys. These are the major drawbacks that we have with what? Centralized repository. That's why in order to overcome all the centralized repositories, okay, we have to use what? We have gone to what? Distributed version control system. Distributed version control system. The next one is what? Distributed version control system, guys. Let me continue this discussion in the next class, guys. That's all for today. What we have discussed in this today's class, see, these are the terms, these are the things that we have discussed. See, introduction to version control system, what exactly the version control system is, and version control system is also known as source code management system and software configuration management or source code management system, and need of a source code management system or version control system. These are the different things, different important points uh, regarding version control system, how version control system works. Okay, with the diagram and with the pictorial representation we have discussed, and basic terminology of what is working directory, what is repository, what is commit, what is checkout. Okay, these are all the things that we have discussed. And benefits of version control system, what are the benefits? Okay, what are the types of version control system? Centralized and decentralized, that is distributed. And what exactly the centralized repository version control system is, and what are the limitations of version control, centralized version control system. Okay, that is what we have discussed, guys. Let me continue the discussion of distributed version control system in the next class, guys. Thank you.